Magandang araw. Ako si Kui Code. Welcome back to my channel where I share my experience as I learn Python. Today I'll be looking into the command design pattern. So the command design pattern is a behavioral design pattern that allows us to turn a request into a standalone object, which contains all the information needed about the request. So this transformation lets us pass requests as a method argument, delay or queue a request execution, and also supports undo operations by keeping track of the history of executed operations so we can revert them if needed. So in this example, just imagine a game where you're putting in a number of inputs that show like directions, like for example, up, down, left, right, and then we're able to redo those. So in my mind, I imagine you have a player. You trying to get through a maze, so you have to push, left, right, up, down to kind of go through the maze. But maybe you only have so many different operations that are allowed to per turn. And then while you're doing those commands, maybe you went the wrong way, so you want to just undo some of those and just go down a different path or whatever. Um, it might kind of seem trivial, but that's not really a big deal when it comes to these because as long as you understand the actual pattern itself, it's perfectly fine to just have a trivial example because the main thing is just to understand it. You don't want to have an example being overly complicated. So first, I'm just going to start with a player class player. We'll define some methods in our init. So we will have our X and Y position. And then we also need a move command and then a move back command, which will support moving forward and then also undoing, which is just basically going to just update it's going to update the XY position. And then same thing with, I don't know why all these enters are here. It's going to update the XY position, and then same thing when you're doing move back. It's just basically going to do the same thing. And then what I'm also going to do is do a move command class down here. And we are going to use data class, which I will have to import. Let me scroll up here. So I can type from data classes import data class. And basically in Python, data class decorator simplifies the creation of classes automatically, which generates several methods like the init method. So you don't necessarily need to include the init because having it as a data class does that automatically. And then we can also just use something called post init to do some special things. So we have a player object we're passing in, which is right here. We have a direction, which is just an enum that we don't have made exactly yet. And then this is just the XY position. So because this is the data class, this is already handled in a, automatically generated in it, but we're just going to use the post in it just to update the actual, initialize these values here. So I'll go ahead and do that. So there's the post in it. So basically the X and Y is being received from our enum direction, which I might as well go ahead and do now. But what I'm also going to do is do self, and then we can do self.player.move, self.dx, self.dy, and then def undo, self dot player dot move back self dot dx and then self dot dy. That's good for that. And then I'll just come up here and do the actual enum. So we'll have to import that as well from enum. Import enum. And then class direction comes from enum. And then we can simply do right equals So this is it's a tuple where the first number is the x value and the second number is the y value. So there is our right. Whenever we uh, go to the right, the x value is going to be increased, which will move the player to the right, and then the y value will stay the same. So I can just kind of copy and paste this. So one will have right, we'll have up, and we'll have left, and we'll have down. So of course, if this is, we have, so for right and down, we have positive values. And then for up, that is a negative value. So the y is going to be subtracted. And then for left, this is also a negative value. So that is our enum. And then what I'm going to do is, okay, this is direction, which is fine. And now we can actually move on to the input handler. So let me just go down. So this is going to handle the actual history. We're going to save all of our inputs here. Input handler. Init self. And then self dot history equals an empty list. And now we can have a couple methods here. So we'll have a handle method, which is going to just call the do function on our move command. And then also, this is kind of obvious, but if you have different commands, you would have a separate abstract command class. And you would just do this command like that. And then you would just be able to pass in any different type of command that you want into the handle method, and then it would still work because all of the different commands will still have the do. So handle self command. For now, we can just do move command. If you obviously have different types of commands, you would just do, you do the abstract one, or you just leave it blank because it doesn't really matter too much in Python. So when we call the handle method, we just literally call the do method on the passing command. So command.do, and then self.history, append command. So then we can just actually save the command that we just did in our list. And now what I'm going to do is do one for undo, self, if self.history is not null, then self.history.pop, which removes the last one from the list. And then this is going to return the actual command, which is, this object. And then we can simply call undo, which is going to call the player move back. So this dot undo. And then we can just do else print nothing to undo or something like that. Okay, and then just for the sake of having a visualization, I will do a method just to kind of print out some stuff. That way you can kind of visually see the actual, player, which will just be, an X in this case. You'll see. So def draw. We'll just pass in the X and the Y. We'll just have it print here as well so you can see. And then for I in range, we'll just do 10. And then for J in range 20, what we're going to do is if I is equal to Y and J is equal to X, then we're going to print an X, because when you this is basically the player's position. So that means that this is just going to make a grid, and for the exact player's position on that grid, you're going to draw an X. Otherwise, you're going to draw, in this case, I'm going to do an underscore. So we'll just print X. And and we need to do end equals an empty space, or n equals null, because you don't want to do a new line, because this is going to be on the j line, and then it's going the y line, which will be down here. We'll just do else. Actually, we'll do this first. Print. That's an underscore. We'll do the same thing for that, and then down here should be there. We can just print nothing, because by default the end would be a new line character. So you'll see when we actually run this. And I think I'll have to, yeah. So whenever we move the player, it's going to draw the entire grid. It's going to do all underscores, except it's going to do an X where the player's position is. And then when the player moves, it's going to redraw it with the X in the new position, so you can actually kind of visually see it moving. So now let me go down. We'll just make a new player, and then handler, input handler. Let me just make sure there's probably going to be some typos here, as usual. Director's not defined. This has to be a capital. Player not defined. Yeah, you should always have your class names as capitals. Okay, now there's no errors, so we're good. So what we're going to do is handler dot undo. So the handler is going to call the undo, but because history is empty, it's just going to print nothing to undo, which is what we're expecting. And there we go, nothing to undo. And now what we need to do is just give it a command. So handler dot handle. Well, what are we passing into the handler method? A new move command. What are we passing for the move command? Well, we pass in a player object, and we pass in a direction. So this can just be pass in our player. And then for direction, we have the enum, so direction dot right. And then that's it. Now we hit F5. I got another typo somewhere. Handler, like that. And now you can see it draws it. So the position of our player is 1, 0. The X position is 1, which is right here. The Y position is 0, which means we're on the first line. So that's exactly what we're expecting. So now I'm just going to copy and paste this. And what I'm going to do is just have an empty input. That way it'll only draw one grid at a time until you press another key, which could just be enter or whatever. And now I'm just going to do a bunch of commands. So I'll just kind of copy and paste this to make this a bit easier. So there's right, down, 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 down. That's supposed to be left. And then we can do the undo as well. So let me go ahead and press F5. So now we can see we're at 0, 1. Now we're at 0, 2, or 2, 0, 3, 0, 4, 0. So we went right 4 times. Now we're going to go down 3 and then left once. So down 3, down, there's 1, there's 2, there's 3, left once. Cool, we're at 3, 3. And now we're going to undo. So because the last move we did was left, we're going to go right by 1 step, which we did. And then before that, we went down. So now we're going to go up if we do another undo. So now we went up. But that's it, we're done. So now we have all of our inputs going in. We can undo them. And then, of course, you can have multiple inputs. And this is going to save every single command. And as I said, normally this would be a command like this. And then because this command would generally be an abstract one, and it's going to have the do method, regardless of what type of command that we do, if it implements from abstract by doing this. That means every type of command you get, you're forced to do the do command, which means here, it doesn't matter what type of command you pass in. it's always going to have a do command, so it'll just do the action regardless. And then same thing with the list, it's going to save all of our do commands or all of our commands, and then you can just undo them. So that works out regardless of what one we need. So like in the future, we can simply just add in a new command, and then it would still work. We don't really have to change any of this code. Um, that's it for this video. So if you found this video helpful, please like and subscribe, and don't forget to hit that notification bell to be notified right away of any new videos. And as always, let me know in the comments if you have any questions or suggestions for future videos. See you next time on Kuya Code. Paalam.